Hello all, we are into the concluding part of the introduction to the Protege in 10 points. So we are in the 8th point where we'll be discussing the case of ordinal classes. So first of all, what do we mean by ordinal classes? So the ordinal classes are basically the classes which have only one individual, right? So basically you can say a class which is equivalent to a class with one individual. Those classes are called ordinal class. Now what one might think that what use it might have, right? So to illustrate this case for these ordinal classes, let us try to define something called the Charles Dickens books, right? So we are trying to define the class Charles Dickens books. So how do we define this? So they should be books in the first place, and it should be having one author, or it should be authored by, or one of the author of this book should be Charles Dickens. Now how do you put that? So for that we convert this individual Charles Dickens into a set or class. Charles Dickens to be a class, and we are putting that class to be the restriction class of this authored by relation. So this is how we do, and actually we have seen that for all the closure axioms that we have put, we have converted in some of the cases converted the individuals into corresponding classes, right? Now let us try to define this in Protege, right? So we'll be defining a new class under say theme Charles Dickens books. Charles Dickens books, right? Now we make it equivalent to book and authored by some, then Charles Dickens, right? So this will be our definition as we have made earlier. So we are done with our definition. Now let us have a look at our individual database, right? So Christmas Carol is authored by Charles Dickens. It should come in our output. FSWT should not come as output. Great Expectations, it should come as output. Impossible Book, no. Linear Algebra, I guess, no. Methods in Algorithmic Analysis, no. Oliver Twist, yes. Yes, I Love You, no. Emperor's New Mind, no. And Hating Game, no. Right? So let us run the reasoner and let us keep our focus on Charles Dickens books and synchronize the reasoner. And we'll see that as expected, A Christmas Carol, Great Expectations, and Oliver Twist, they are coming as the instances of Charles Dickens books, right? So we have demonstrated the case of ordinal classes, and they are very useful in the scenarios where we need to put one individual as the restriction for a particular property in a restriction class. So coming to the next point, we will like to discuss on the case of transitivity, right? So how do we define, or if we define a property to be transitive, what will happen, what kind of inferences we can draw, right? So we are talking about transitive relations. So for that, in our database, we have a property called influenced. So this influence we define to be transitive. And if A1 influenced A2 and A2 influenced A3, then we can infer that A3 influenced A1 influenced A3. So let us have a quick demonstration of this in Protege. We will not be doing anything on the classes. So let us have a look at in the object property. We have got influenced, and influenced is marked as transitive, right? Now in the individual, so let us look at the authors. Go to say Robert Louis Stevenson and assert one object property that Robert Louis Stevenson influenced say Vladimir, right? And let us go to Vladimir and try to assert one object property which is influenced say ZD, right? Now if we do so, we are not doing anything on the class definitions, so we just synchronize the reasoner. Now if we synchronize the reasoner and go to Robert Louis Stevenson, we can see that we have inferred that Robert Louis Stevenson has influenced Z.D. Smith. So this is what we have inferred, right? Now let us try to remove this characteristics of influence. So we just remove this transitive. So we are this influence is no longer a transitive property, right? Now let us sync this reasoner. Now you see that no longer Z.D. Smith is influenced by Robert Louis Stevenson, right? So we have a demonstration of the transitive property. So we are at the last point, which is basically the 10 point. And here lastly we'll be discussing about very important thing, which is complement. So negation of some class expression, right? So first of all, let us try to demonstrate the complement of a set. Complement of a, right? So let us go to Protege. There we will not be creating new classes. We just play in the DL query box. We'll be just querying the database using some class expressions here. Okay. So what we want to know, the complement of academic, right? So let us try to find the complement not of academic. And we know this academic is basically kind of set or class. So for that we want to see what are subclasses of this complement of academic, right? Now if you execute this, you see this biblical fiction is a complement of subclass of the complement of academic, right? Comedy is a subclass of the complement of academic. Fiction is a subclass of the complement of academic, and non-fiction is a complement of academic. So this is how you can see that if we take the complement of a class, so other classes which are complement to this is coming into it, right? Now let us try to model a different kinds of scenario, a more elaborate kind of scenario, right? So what we are trying to do, So we are going to the second case. We are trying to model something like this: book intersection not of there exists has genre academic, right? So what we're trying to see here, say you have a book B1. B1 has some genre, uh, so has genre, the mystery, right? And which is not really is something not belonging to academic, so does not belong to academic. So this says that a book does not have any relation that is of type any genre that is of type academic, right? So this is one thing. So let us get to this point, right? So let us move to Protege, right? So what we have, so let us go to a book. Let us take, say, Great Expectations. So it has got genre to be mystery, right? And which is basically something different from academic. So it should come as our output, right? So let us try to run this reasoner, and what we expect to see that will be kind of in our output. So we should expect this great expectation to be the output of this class expression, and not of, so let us put bracket for safety, not of has genre some academic, right? So this is what we are trying to get. Now we'll be trying to see the instances instead of subclasses, but we are not getting any result, right? So we expected that great expectation would be a kind of result here, because great expectation is authored by, sorry, has genre mystery, right? So basically what is happening, let us have a closer look at it. Now if you put this not inside, so this sum will convert to all and this academic will convert to not academic, right? So these two will be kind of equivalent expressions, right? So let me write it down here. We'll be wiping out later. So this second part, I'm just highlighting this part. This part is equivalent to something like has genre then only not of academic. Now, as we have this only, which is kind of all values from, and we know that for all values from, we need a closure axiom. Otherwise, we do not get any such results, right? So let us do that. We put one closure axiom by closing the set of genres that great expectation can take, right? So we will just put has genre only, sorry, has genre only mystery. Now if we do so and try to synchronize the listener, you see great expectation is coming as our, right? So we have seen that in case we do not put the closure, we don't get this great expectation as output. And in the other case, if we put closure, we are getting this great expectation as output, right? Now let us move on to the third case of the complement, right? So we are moving on to the third case of complement. Now the third case of complement is looking like similar. So we have the similar kind of expression with a little bit of difference. There exists as genre not of academic. So this is the case of not some, and this is the case of some not, right? Now, what is the kind of visualization that we can think of? The B1 has got genre as genre to be, say, uh, mm, the essays in physics. And this belong to non-fiction, right? And this has genre to be, say, physics. And which is basically belonging to, at the end, the academic. Right. Now what we are saying here, that it has got at least one genre that is not academic. So if we try to run this, if we try to execute for this data, so will this be satisfied? So this first thing, will this be satisfied? So let us try to check it. So it is saying that it will be having only genre which are not academic. But here we are having one such case, which is this case, which is belonging to academic. And that's why this B1 should not belong to this, right? So this B1 should not belong to this definition. So let us name it to be B2. So B1 will belong to this, but B2 will not belong to this. Now check the case here. So you have book, and then there exists at least one genre that is non-academic, right? But so here you have a case like B1 is having a genre to be mystery, and this is basically is a non-academic genre. So this B1 will be coming as output. B1 will belong to this. Now let us check this. So this B2 has got one genre to be, say, essays in physics, and that is non-academic, right? So in that sense, B2 will also belong to this particular statement. So let us have a demonstration of this. So for this, we'll be selecting this Emperor's New Mind, so which is a kind of having genre to be physics and genre to be physics essay, right? And this physics is belonging to the physics domain, and this physics is basically, so let us have a look at it. So you have a physics domain, and this particular physics, you can see the small physics is belonging to this physics class domain. And physics essay is a genre which belongs to the non-fiction domain, right? So you are having the case 2, where you have got two genre. Let me again move to the visualization. So you have two genres relation. One out of them is belonging to non-fiction, the other is belonging to the academic, right? So we have this case, right? Now let us see where it will belong to, right? Now let us first run this query. We have already executed this query, the earlier one, and we observe that great expectation was coming to be the output for this, but not emperor's new mind, right? Now let us change it a little bit. So the change would be according to the specification that we have mentioned. So it will be has joiner sum, and this not will be put inside. And let us put one bracket here, right? Now if we try to execute this, now you see that emperor's great expectation is there. So this expectation is basically representing B1 in our slide, right? And this emperor's new mind is the B2. So in for this case 2, the second expression, we see that both great expectation and the emperor's new mind, they are coming as the instances of this particular expression, right? So with this, let us conclude the session on the introduction to Protege with 10 points. And again, I'd like to remind you that this is a kind of introductory lecture for understanding the functionalities of Protege and the relation between Protege and OWL. But also, there are many things beyond this. As you explore the thing, we'll get the things in a better way. But before ending this lecture, let us have a look at what kind of output that we have got in terms of the serialization of the ontology, right? So what we'll be doing, we'll be looking at the corresponding RDF XML representation of the ontology that we have created, right? So for that, we have already saved. Let us save it once more. So we are going to Protege, we are saving it. Then we are moving to the file where this particular ontology is kept in a serialized form, right? So if we try to move through, we just have a quick look at this ontology. So this is one RDF XML document. We have got all the prefixes declared here, and most importantly, you can see that we have the base URL to be the prefix that we have defined earlier. So this is the prefix that we have defined earlier. This is the prefix, right? Now with this, let us try to see what are the kind of things, some of the things that we have defined. So for example, we have defined authors to be one object property, and this is an inverse of authored by, right? So this is what we have discussed. Also, we have defined the domain of uh, author to be author and range to be book. So that is what you can see here, right? So also you can see other things. Let me check whether we can go to, let us, okay, let us have a look at this. So we have defined one object property which is influenced, and it has got domain to be author and the range to be author. So, and so these are the kind of data type properties that we can see. This is the definition of academic publisher, right? So this academic publisher is a subclass of publisher, and also published. So this is a kind of restriction class, right? Published, and the restriction is on the property has genre, and the class for the has genre restriction is academic. So you can do one-to-one correspondence between the kind of concepts that you have defined and the serialization file that you have obtained out of saving the ontology graph into the form of XML, right? So with this, let us move on to the end of this lecture. Thank you very much.